Assalamualaikum warahmatullahi wabarakatuh. We are from BMMH Section 1/2. In this video, we would like to present about the topic free body diagram from the actual structure. Type of structure that we choose is the rocking chair. We would like to introduce our lecturer, Dr. T.S. Suryati binti Akmal. In this group, we are having 3 members, which is Muhsin Amili bin Nur Rosli, matrix number B092010-241. Next, Muhammad Syafiq bin Muhammad Sharif, B092010-339. And lastly, me, Nurul Fatihah Akmal binti Muhammad Zain, B092010-374. First of all, we would like to share the actual rocking chair. The objective, first, to draw the free body diagram, the rocking chair. Second, to identify the force exerted on the system. Next, we are provide the free body diagram and calculation. There are 3 types of system that we find. The free body diagram of system 1, we assume that the weight of rocking chair is 10 kg. Weight 10 kg multiplied by 9.81 and the equal is 98.1 Newton. The force X equals 0. FBA cos 30 degree minus FBC equals 0. So FBC equal 0.87. Then force Y equal 0. FBA sin 30 degree minus 98.1 equal 0. So 0.5 FBA equal 98.1. FBA equal 98.1 divide 0.5. And the FBA got 196.2. Then the value of FBA into value of FBC. So 0.87 FBA equal FBC. 0.87 multiply with 196.2 equal FBC. So the FBC is equal 170.7. That's all. Thank you.
Okay, Assalamualaikum. My name is Muhsin Amili. Today I'm going to present the system number 2. From the diagram, we can see the system number 2 have 3 different force acting on the system. From the FBD that we drawn, we can see the acting force on the system clearly. F1, F2 and 29.43 Newton from the 3 kg. For the calculation, Fx equal to 29.43 Newton plus F2 cos 60 degree minus F1 cos 60 degree equal to 0. Then we can arrange the equation and you get F2 cos 60 degree minus F1 cos 60 degree equal to 29.43 Newton. From the equation we arrange, we can see that F2 and F1 have the same force. And for that, we have to consider the plus minus value of the force. For F1, negative F1 cos 60 degree equal to 29.43 Newton. And we get F1 equal to negative 58.86 Newton. For F2 is F2 cos 60 degree equal 29.43 Newton. For F2 we get 58.86 Newton. Thank you for watching.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq bin Muhammad Sharif. My matrix number B092010-339. Now, I will explain about the system 3 from our project. Okay, this is the FBD for the system 3 in our project. And this is we draw again the FBD. We insert the y-axis and x-axis here and here. Now let's move to the calculation. From this FBD, we can find the summation of fx and summation of fy. We assume the angle for the FDC is 60 degree. So to find the calculation, we assume the force from the left to the right is positive. So the summation of fx equal to 0. The force acting on the x-axis is FDE minus FDC cos 60. This FDC cos 60 equal to 0. So because there is have two unknowns, we need to find the other force at y-axis. So we assume the force from the bottom to the top at the y-axis is positive. So summation of Fy equal to 0. The force that acting on the y-axis is negative FCD here, sin 60 degree equal to 0. So FDC equal to 0.87 Newton. So after we get the value for the FDC, we can find the value for the FDE. So the first thing we need to do if we want to find the FDE, we need to write this equation again on the new place. So FDE minus FCD cos 60 equal to 0. So FDE equal to FDC cos 60. Because we want to find the FDE, we need to remove this FCD cos 60 to the right place. So the DC value we get before this is 0.87 Newton. So we replace it into the equation and we get the value for the FDE. So the FDE equal to 0.435 Newton. Okay, that's all from me and thank you.